In this set of problems, we're going to look at how you can write a Taylor polynomial when you're given a table like this. This is a common type of AP problem, and in fact, these are all from old AP exams. So, in this one, we're given a table of derivatives for some function h. We don't know what h is, doesn't matter. Question says, write the first degree polynomial for h about x equals 2. So that means our center, c equals 2. And use it to approximate h of 1.9. So first thing I'm doing is if I see a Taylor polynomial, I'm going to write down that formula. So we have f of c plus f prime of c times x minus c. Oh, and hey, good news, it says first degree. So I don't actually have to write out any more than that. I'm only going up to that first degree term, x to the first. Okay, and actually our function was h, not f, excuse me. So this should really be h's. And then we knew that c equals 2. So this will be h of 2 plus h prime of 2, x minus 2. I'm just putting in 2 for c. Now to actually write this polynomial, all of these values are in my table. So I don't have to calculate anything. H of 2, I look up in my table, and that is 80. Plus h prime of 2, if I look in the table, is 128 times x minus 2. So we've done the first part of that question. Write the polynomial. So I'm going to put a box around that. We're going to get some points for that. Then it says use it to approximate h of 1.9. We're going to approximate h of 1.9. All you have to do for that, it's giving you an x value, 1.9. I'm just going to plug that in for x in my polynomial. So 80 plus 128 times 1.9 minus 2. And if I get out my calculator and figure out what that is, oh, look, I already did it up here. 80 plus 128 times 1.9 minus 2 is 67.2. So there's our approximation. Now, the last part of this question says, is this approximation greater than h of 1.9? Explain. This is a bit of a weird one, but it's only worth 1 point. So if you didn't get this one, it actually would be fine. But the real value of h, we have to know what that graph is going to look like. So if I look at my table, it looks like h is all positive numbers. H prime is positive. That means that h is increasing, right? If it has a positive first derivative. And h prime prime, the second derivative, is all positive numbers, which means that h is going to be concave up. So h is going to look something like this. This is h. And my polynomial, if we look at what that graph would look like, 80 plus 128 times x minus 2, that's a line. That's the graph of a line. And the polynomial is going to touch the graph of h at that center, at 2. And so if a line is touching this graph, the only way for that to work is if the line is underneath that graph. It would have to be under. So that means that our approximation is actually going to be less than the true value of h of 1.9. And we could justify that by saying it's less since h is increasing and concave up. And the picture helps to justify that a little bit as well.